Okay, so here we're going to do another example using trigonometry to find net force. In this case, we've done this example using components in a previous video, and now we're going to solve using just triangle math. And if you look at the question, this is question number 3 again on your lecture examples, under net force in 2D. And you've got two children pulling, one with the top force, one with the second force, and where's the thing going to end up going is the question. And you could easily represent that using a triangle, and so that's how we'll solve this particular example. So if you want to get that down, and then on the next, we'll draw the triangle and solve for net force that way. Okay, so again, keeping in mind net force, F1 plus F2, they're all vectors, so we're going to make a triangle out of this, as close to accurate as we can. So it's going to look something like this. First draw F1. So F1, there's just a little coordinate system, so I have something to base my angles from, and it's 35 degrees east of north. So it's going to look something like this. So this is 15. And if I was going to keep drawing up here, we have in there 35 degrees. After that, we need to add our second vector, which is 25, and it's north 54 degrees west. So north, and then north is up and 54 degrees to the west, and it's a bigger 25 degrees, something like that. So this one is my 25. Here's my 54 degrees. And my resultant vector then is from where I started to where I ended, and where I start. So this must be my net force vector. Okay, a couple things with the angles here, because if I want to use cosine law, to solve this, I need to know the angle across from my net force vector. That means I need to know this angle here. Well, I know this is 54. That makes this 36 right there. And the other thing I can say, using my Z rule, is this angle right here must be equal to this angle right here. And that would be 55 degrees. The reason it's 55 degrees is because on this coordinate system, this part is 35, this would be 55, so it all adds up. So 36 plus 55 is 91 degrees. So if you don't see that, stop the tape, just think for a moment, go through it yourself and see if you can work out that 91 degrees across from my net force. Now it's a simple matter of using cosine law. And you end up with net force is equal to, similar to the last question, 29 newtons. So, because I've solved this problem already using x and y components, when I get a number of 29, you know at least that everything's working out okay. Now, the next thing I'm going to need is this angle here. And I'll use sine law to find the full angle, and when I get it, I'm going to subtract 35 to find out how many degrees my net force is west of north. Okay, so ultimately I want this angle right there, but I have to find the full angle first using sine law. So sine of theta over 25 is sine of 91 over 29. And you work that through, and you should do that on your own, but I'll leave it to you to get 59 degrees. Okay? So, if this whole piece is 59 degrees, and this piece of that is 35 degrees, my little dot here must be 24 degrees. So therefore, my net force is going to be 29 newtons, 24 degrees west of, I think in the last example we had 67 degrees north of west, and you can see that I'm within 1 degree, which is about makes sense because depending on where you hold your decimals along the way, you might get a slightly different answer. We have the same force and just we're 1 degree off in different angle. Okay, well, got a good answer.